Okay, so this video is going to take us through the remainder of the history of the periodic table. Um, as you recall from class, you developed your own table based on Mendeleev's rules, and I wanted to show you what Mendeleev's table looked like. This is, as far as I can find out, uh, sort of a neatened up version of his periodic table. He had, just as you did, rows of elements that had similar reaction properties, and he had his tables numbered from atomic mass going down like this, as well as going across the way like this. So going up an atomic mass like that and like that. Now, a couple of things to notice. First, these commas there are his way of writing a decimal, so that's 65.2. One of the things that Mendeleev noticed in his periodic table were these gaps. And these gaps were places where he predicted there would be some new elements found. Now, he wasn't the only one to make a periodic table that included both stuff about the reactivity as well as going up by atomic mass in sort of both directions. This gentleman here is a scientist by the name of Mayer, and he apparently came up with a similar table in the 1860s also. Mendeleev, however, gets most of the credit in the history books for discovering or creating the first periodic table. In fact, really the father of the modern periodic table, because he went ahead and made a prediction about the properties of that element right there. And that was more than Mayer did. Mayer simply made his table but didn't make a prediction. And this element here was the first element that was found after Mendeleev made his table. Now, that element, let me show you something else here. Somebody has suggested that Mendeleev's table would work better if turned on its side. Not so much the writing, I just didn't want to retype all this, but lining up the elements with common reaction properties going down in columns. It's not obvious to me why that's easier, but that's certainly the way our modern periodic table is set up. So there probably is a pretty good reason for that. Anyway, here's that element right here. And that was discovered either after Mendeleev's table was made and after he made the prediction, or somewhat at the same time. But the interesting story about it is that the scientist who discovered this element, it's called gallium, sent to Mendeleev the properties that he had measured for that brand new element. But because Mendeleev had very precise sort of mathematical relationships between these elements, he had a very good sense of predicting what the properties of that unknown element would be. And when the scientist sent the data on those properties to Mendeleev, Mendeleev sent them right back and said, well, I think you found that element, but you've done a bad experiment. Your numbers for the properties are way off, or at least somewhat off. And there was some dispute there, but ultimately the scientist went back, remeasured, and in fact, Mendeleev had been correct. The ability of his table to predict the properties was quite astounding to scientists at that time. Well, a number of years passed, and many of these gaps got filled in, many of these elements got found, and by around 1900, the periodic table looked something like this. It was sorted by rows for similar chemical properties, and I've color-coded all of the elements that have similar reaction properties. But if you take a look at that, you'll notice that the model, the periodic table being sorted by atomic mass as well as properties, reaction properties, is beginning to have some issues with one of our three criteria, particularly not consistent with observations. You'll notice right here and here you have two elements which certainly go up by atomic mass but do not have are not in the right column based on their properties. Same thing goes with potassium and argon, and also tellurium and iodine. And so by around this time, there were enough cases where the model, the periodic table, wasn't fitting observations that it probably needed to be modified. And that was done sometime in the early 1900s. I've been unable to find a reference for who exactly decided that we should number the periodic table not by mass, but by just by numbering, starting with the number 1 up here, and 2, and 3, 4, 5, 6, 7, 8, 9, 10. And that way we get argon to be in the proper column, and we get potassium to be in the proper column. We get nickel and cobalt to get reversed, and now nickel is with the elements it's similar, and so is cobalt. And the same thing goes with tellurium and iodine. They switch places, again, based simply on putting them in the right spot, and then renumbering the periodic table by just giving it a special number. It was called the atomic number. But to me, it's kind of interesting that at the time, the atomic number had like 30 there for zinc, had absolutely no meaning whatsoever, other than now we get all the elements in their proper columns based on reactivity, and we simply assign the elements a number based on their location in the periodic table. Largely, the state of the periodic table remained the same for another decade or so, but in 1913, this gentleman here, this is Moseley, and he did some interesting experiments where he made sent X-rays at various elements, and through a lot of science that is well beyond us, determined a neat mathematical model that related the X-rays, something about the X-rays, to the number of protons in the element. Protons were known, but the number apparently was not. And that number of protons corresponded exactly with the number given to the element when the table was rearranged from atomic mass to atomic number. And so in 1913, for the first time, we understood where these numbers came from. Again, prior to that, they were simply a number given to an element based on its placement in the periodic table. But Moseley figured out that, in fact, this atomic number was equal to the number of protons. And so, really, with one simple, fairly simple experiment, Moseley was able to do two very important things. First, he was able to confirm the atomic number as a meaningful number, and therefore sort of cement the periodic table's current set of ideas, numbering by atomic number and by chemical reaction properties. The other thing he was able to do was confirm the idea of the nucleus. In fact, at that time, the nucleus was somewhat assumed, but not entirely accepted by the scientific community. And even though Rutherford had proposed it, a decade and a half earlier, but it wasn't until Moseley was able to give some details of that scientists realized that, in fact, the nucleus was something that existed. And so Moseley earned credit for doing sort of cementing two models in sort of the scientific base of knowledge. Well, that's the end of the sort of the rest of the history of the periodic table. There is a little bit more, but we might save that for another day.